Hello, student, and welcome to Control and Protection 1 course. Inshallah, before you go to the lab, you will be able to understand through these videos, inshallah, the theory behind each experiment. And you need to see those videos to be ready before you come to the lab. And once you enter the lab, you need just only to do the connections and take the readings. This course has been prepared to give the student a thorough understanding of the theory and operation of electrical motor controls. Starting with fundamentals, it proceeds step by step through all the basic kind of controls the student will encounter in industry. It explains what kind of controls are available, how they operate, where they are used, and why they are designed to operate as they do. Inshallah, you will be able to design and draw your own control system using schematic line and wiring diagrams. Before I go through these slides, I would like to mention one important note. To prevent the spread of COVID-19, you should wear your mask, clean your hands, keep a safe distance. Okay, guys, to make sure that you understand what is control, I built up this circuit for you. It is a simple circuit. This is your location, guys. Okay, this is your location. I will explain why. This is the supply that we need to operate or to supply this motor. Let us say that this motor is 3 kilometers away from you. So it is far away from you. The simple thing that you need to add here to operate the motor, because here is open circuit, you just need to add a normal switch. Okay, this normal switch, this is the basic, to be honest, guys, this is the basic control system. Once you have load and you have a switch and you have power supply, خلاص, you just close the switch and the motor will run. Now we close the switch, motor will run. So it is on. Okay, guys. Now, once I disconnect the switch, okay, guys, the motor will be off at this moment. Once I open the switch, okay, guys, the motor will be off. This is the simplest control circuit that you will find when you control a motor. Now, because this motor is 3 kilometers away from you, it is not possible to go every time from your location to the motor, check if it is on or off, and then come back to your previous location every time. This is useless. So it is better to, okay, guys, it is better to put a lamp. Okay, let us put a lamp in my location. This is simple lamp. Okay, this is simple lamp. So once I connect the switch, okay, guys, sorry. Once I connect the switch, okay, this lamp will be on, the motor will be on. Now, once I disconnect the switch, motor will be off, sorry. Motor will be off and the lamp will be off. So also now, why do we add this lamp? Because it is not easy to go that 3 kilometers every time to the motor. So just only by connecting the lamp, we know that the motor is on or off. Let us assume that you already closed this switch. Of course the motor will run. But you forget the switch, you forget to disconnect the switch and you went home. The motor will run all day long, and this is not healthy for the motor. This is not safe. And also the switch will not withstand the high voltage and current for long periods. That's why we use a push button. A push button is basically it's like this. So once you depress the push button down, you will close the circuit. Okay, you will close the circuit. The motor will run. Now the other way around, once you release your finger, okay, once you release your finger, the circuit will be cut here and the motor will be off. So this is the normal condition. That's why we prefer push button. But the problem here now, if I need to operate the motor for 1 hour, guys, so I will just press the push button and hold for 1 hour, and this is not good practice. That's why we need a contactor, guys, here, because the contactor has normally open contacts and normally close contacts. In normal conditions, here the current will flow. Normal conditions, here the current will not flow because it is open circuit. Inshallah, I will explain more about the electromagnetic contactor in the coming slides. Slide number 3 talks about the contact, okay, that we already explained for you, the contact, the normally open contact here, okay. So a contact consists of a conducting part that acts to complete or interrupt an electrical circuit. So it is acting to close the circuit. Interrupt means open the circuit. So this is an example for single break contact. It breaks or connects the circuit from one location, guys, here, one location. This is the double break contact. It breaks from 2 locations, from this location and this location. So okay, if I depress the push button, it will break from here, it will break from here. Okay, this is the double break contact. Now, for normally open contacts and normally closed contacts, this is the normally open contact. As you can see here, the normal condition is open circuit. It's open circuit. The normally closed contact, okay, the normally closed contact, its normal condition is closed circuit. Okay, these are the symbols. This is normally open, normally closed contact. Now, for the switch, a switch is a simple device for making, okay, making, guys, means closing the circuit, breaking the circuit to disconnect this, the circuit, or changing the connection in electrical circuit. Means I have to this is the input, okay, we have 2 output, okay, and this is the switch here. So this is circuit A, this is the circuit B. So when I say changing, means that I change the power from circuit A to circuit B. This is the meaning of changing. Making means closing the circuit. Breaking means disconnecting the circuit. Okay, a single pole switch, okay, guys, a single pole switch is used for only one circuit, for only one circuit. Double pole switch would be used for two circuits. Okay, so what do I mean by poles? Okay, poles, they are the input for the switches, the input for the switches. And when I say a single pole, means I have just only one circuit. When I say double pole, means I have two separate circuits. Throughs, the throughs is the how many different output connections that I have. When I say single through, means I have one circuit. Double through means I have two output circuits. So this is an example for the single pole. I have one input, I have one output. This is single pole, single through, single pole, single through. Okay. This is the single pole, single through that I told you. Okay, this is the single pole, single through. I have one input and one output. Single pole, double through, it means I have one input and double output. Double output means two circuits. When I say double pole, single through, I have two input and one output. For the double pole, double through, I have two input circuits and two output circuits. Now for toggle switch basically it is a three-way switch. Okay, three-way switch. This is very important to know because three-way switch is to control one load from two locations. Like to control one like lamp to control from two locations, to switch on and off from one location and switch on and off from the other location. Now it is a manually operated switch. When thrown, breaks normally close circuits and makes normally open circuits. This is the normally close circuit, normally open circuits. This is the input. Okay, 1, 2, 3. This is the lever. Okay, this is the lever to switch between two circuits. Okay, this is to switch between two circuits. A toggle switch is actuated by moving a lever back and forth to open or close an electricals. Now, regarding the push button switches, as you can see here, guys, this is the push button. I have it here. This is here. You'll find the diagram of the push button. I have two. I have here normally close contact. I have here normally open contact. This is 1, 2. This is 3, 4. So when I press the push button down, 1, 2 will be open. 3, 4 will be closed. Okay. This is for this push button. Here also the same idea. I can connect the circuit for this push button. This is the normally closed contact, and this is the normally open contact. This is also the normally closed contact for this push button, and this is the normally open contact for this push button. A four-way switch. When you have a load and you need to control the load from 3 or more locations, okay, as you can see here, from 3 or more locations. So you need to have, as you can see here, by placing one or more of these four-way switches between 2 3-way switches. This is the load, like a lamp, and this is the supply. As simple as that, guys. This is the three-way switch.
three-way switch, okay, and this is the other three-way switch. So this is the single line diagram, okay guys, single line diagram. So I have two from location number 1. This is the location 1, this is location 2. If I need a third location, I need to have 4-way switch here for the third location, and so on. If I need fourth location, I need to add one more 4-way switch. Now for the electromagnetic contactor, contactors are devices for repeatedly establishing and interrupting an electrical power circuits. When the contactor is energized, normally open contact closes and normally closed contact opens. That's mean, guys, this is the electromagnetic contactor. Here we apply the voltage 120 volt, okay. Here are the normally open contacts, okay. I will just draw it like this, okay. Here are the normally closed contact, okay, and so on. So once I energize once I energize the coil here, okay, so those normally open contacts will close and those normally closed contacts will open. As simple as that, guys, okay. And this device, you will find it in almost all the experiments, inshallah, in control and protection one. Okay. Now for the time delay relay, this also works almost the same as the contactor, but has more extra feature, which is when I energize the coil here 120 volt, okay, I have normally open contacts and normally closed contacts. I agree with you. This is sorry. Okay, this is normally open contacts, normally open. This is normally closed, and also it has something called TDC, time delay close. Time delay close. This is the one. It has it is with time. Okay, so time delay close. After time, it will close. Okay, it is open. After time, it will close. After time, and time delay open. After time, it will open. Okay, after time, it will open. This is the extra feature that has over the contactor. Okay. Now for the overload relay, this device is a primary control device to protect motor against excessive heavy loads. So here I connect the supply. Okay, here I connect the supply. Here I connect it to the load. Okay, and this is the control circuit. We don't need it now. I will explain it later. So once I have extra current here, excessive current drawn by the motor, this device will sense the overload on the motor and it will trip. Okay, it will open the circuit. Now, circuit breaker. Circuit breaker is the most important part in the control system. This device is designed to open and close circuit by non-automatic means, and to open circuit automatically on a predetermined overload current. This device, so when I have short circuit, okay, this is for safety, okay guys. When I have short circuit, it will have high current, right? So this circuit breaker will trip to disconnect the power supply. Okay, as simple as that. And it is the main device in the control system. Now, control transformer. This is that we know already to have. You remember that I told you about the power circuit, power circuit, and control circuit. Okay. So from the name, it is a control circuit, and it is transformer. So the usually the control circuit needs 120 volt. Okay, and the power circuit usually it is 220 volt. So we connect it here, the 220, and we will have here 120 volt. Okay, so this is for the control circuit. So it is control transformer to step down the voltage. The main use of this transformer is to step down the voltage from 220 volt to 120 volt for the control circuit. Okay. Slide number 16 talks about pilot control devices. I'm going to mention their job in a control system, and I am going to give you some examples. A pilot device is a device that provides indication. Okay, guys? Indication. This is the first job of pilot control devices. The second job is control of a process. Okay? As an example for indication, you can find indicator lamps in a control system. This second job, which is control of a process, you can find some examples like push buttons, okay, float switches, control relay, toggle switches, etc. So at any time, you can control the process by pressing the push button, and you know these pilot control devices direct the operation or control of the primary control devices. This is an example of a pilot control device. As you can see here, this is a small sample of control system which consists of power circuit. Okay, this is the power circuit of this control system, and a control circuit. Okay, this is the selector switch. Okay, it can control the process by changing its position. Okay, it can control the process by changing its position from stop to run. I mean that it can stop the motor or run the motor. So once I change this position to run, then the motor will run. That's why it is a pilot control device that controls the process. If you go, inshallah, to a company, you will see for sure this kind of control panels inside substations. These control panels give you the opportunity to see some indication lamps for the controlled process, and some push buttons for switching on or off a machine or any available devices. Slide number 19 talks about control relay. This type of control relay is used usually as a protection for DC operations, like in a synchronous generator, to be exact, for the loss of field. Loss of field is experienced due to interruption of the field DC source. This type of control relay, as you can see here, this is the type that I am talking about. It is a single pole double through. Single pole, okay, double through. Slide number 20 talks about sequence timer. By the way, this is also a pilot control device because it controls the process. It is used when a different on or off process or a sequence of successive operation must take place within a given time interval. So, let me give you an example. If you have a motor and you would like to run the motor for 4 seconds, then stop it for 2 seconds, and you need this process to be repeated. So this is the kind of device that you will need. Now, for drum switches, this device is used to manually control the motor. By rotating the lever handle, the drum switch can start, stop, and control the speed of AC and DC motors. When I say control the speed, of course I meant by changing the connection of the motor, or even switching to other circuits that allow such a purpose. Plugging switches, this sensing device mechanically connected to the motor shaft to provide electrical switching that is dependent on the direction in which the motor is running. One typical use of plugging switches is for machine tools that must stop suddenly at some point in their cycle of operation to prevent inaccuracies in the work or damage to the machine. Another use is for processes in which the machine must stop completely before the next step of work begins. Now, for magnetic brakes, it is a device that mounts directly to any EMS motor module faceplate, which is the kinds that we have in the labs. It provides holding torque when energized. It's used to stop the motor. For plugging switches, guys, the motor will stop, but you can go for reversing the motor after standstill position. In case of magnetic brakes, once it is energized, it will force the motor to stop, and you cannot go for reverse without de-energizing the magnetic brake. This is the difference between those two. Now, this is the last slide for today. It talks about the buzzer. The buzzer is a device used for offline testing. Inshallah, you will find this device, this buzzer, in the lab for the first experiment. It is used to detect any open circuit. Make sure that, guys, you will not connect this device when there is power in the circuit. Make sure it is an offline circuit. Okay, this test buzzer is an audible device used by electricians to identify wires and terminals that are directly interconnected. It determines whether switch contacts are open or closed, or whether wiring is short-circuited. Unlike an ohmmeter, the buzzer will not indicate circuit continuity if any appreciable resistance is present. This is all about this pre-lab video. I hope inshallah you enjoy it and you find it informative. Thank you so much for watching this video, and stay safe.